cluster of excellence, PLAS PAR federates about 150 leading plasma scientists in Paris area. We create bridges between many fields, from astrophysics to fundamental plasma physics and also to industrial plasmas. It allows to stimulate the emergence of new ideas and to provide a unique pole to attract young scientists. PLAS PAR has set an ambitious roadmap based on the study of fundamental processes in plasma, on the development of new simulation codes, and on innovative experiments and observations.
I work in Lully. With my group, we study the interaction of powerful laser with matter and plasmas. The application of our work are many, so we study particle acceleration at very high energy, we study shock creation, and also we study the solar wind and the radiation emission due to the electrons of the solar wind, and this last work is in collaboration with the LASIA laboratory. So one of the important results that we get is that we were able to study the conditions in order to reproduce in the laboratory phenomena that are important in astrophysics, and then we were able to identify the condition to create magnetized shock by laser-plasma interaction. The next challenge is related to Apollon, and this laser will produce extremely intense fields, and thanks to that we will be able to study the fundamental properties of matter.
I'm working on the project FAR, funded and fostered by LabX PLAS PAR, with a close collaboration between LPP and LERMA. Our ambition is to provide an easily extensible, state-of-the-art, petascale hybrid particle-in-cell code to the PLAS PAR community in order to study cold plasmas, space plasmas, and high-energy density plasmas. We have already set software engineering practices, and we are currently selecting and testing hybrid peak numerical methods combined with adaptive mesh refinement.
I'm working on the dynamic of magnetic reconnection driven by laser. Two laboratories are involved in this project, the LPP and the Lully. Magnetic reconnection usually is associated with aurora. The idea is to reproduce this phenomena with laser. Up to now, we succeeded to conduct experiments to characterize and analyze this phenomena. The next step is to reproduce this experiment at higher energy. For this, we will use LMG PETAL facility, which is a petawatt laser facility at Bordeaux.
At Onera, we're working on a new thruster technology for satellites with the support of PLAS PAR. This technology is called ECRA, and it's based on the ECR physics with microwave power. It has many advantages over current thruster technologies. The results we obtained recently are very promising, especially since we improved on the design of the thruster. Now we have to improve on the performances of the thruster, improve the understanding of the physics inside the thruster, and also increase the power level of the device up to 1 kilowatt, which is what is used right now on satellites.
At LPP, we are developing new concepts for space propulsion, and we do that by combining fundamental research with the development of prototypes and dedicated experiments and also simulation. We have reached a proof of concept of two technologies that are patented by CNRS and the École Polytechnique. And the next challenge for us is to really make this in orbit and control small satellites in space.
The project Étincelle, funded by PLAS PAR, aims at developing a new instrument at LPP in collaboration with Technical University of Eindhoven and LPICM to measure surface electric field on catalytic surfaces developed at D'Alembert Institute.
CO2 recycling considers the use of CO2 for the production of fuels and chemicals by passing the use of heavy hydrocarbons. The coupling of a non-thermal plasma with a proper catalytic material is seen as one of the most promising technologies to reach this goal.
It will be the first time ever that the CO2 conversion in plasma can be related to the surface electric field. This will open the door to a complete rethinking of catalysis.
The LPP is involved in plasma medicine with the support of PLAS PAR. We develop innovative therapeutic strategies based on plasma to face with cancers and dermatological issues. We collaborate with the CIMI and LIB research centers on oral squamous cell carcinomas. We have already demonstrated a therapeutic effect on cell cultures, which allows to work now on in vivo experiments, and we are obtaining very promising results.
For me, PLAS PAR means excellence.
Building bridges.
Challenging and fun.
Cross-fertilization.
Neighboring research excellence.
A great accelerator.
project catalyzer.
Exciting!